Hi friends, welcome to Unacademy. Hi Nalinakshi, welcome to the class. As you all know, Unacademy offers plus courses for Karnataka CET students. Students who are writing CET in the year 2021 can subscribe the plus courses. Now, plus courses are, meant for those students who want to excel, who want to achieve great success in CET 2021. Now, what is a plus, classes or a plus course? It is a structured live course, as you can see here, structured live courses where both class 11 and class 12 topics will be done in detail. There will be also live doubt clearing sessions, and these doubt clearing sessions are helpful in clarifying the doubts. In case if you have doubts regarding the topic, you can ask and clarify and strengthen your concept. We also have quizzes at regular intervals, and these quizzes are for self-analysis. Now, when we say quizzes, student, it is actually you will understand whether you know the topic very well. You will also understand the quickness with which you are solving the problem. Is it enough? So, quizzes are specially meant for self-analysis. The comprehensive batch has already begun, so you can join the batch by making use of the code BHAVANILIVE. Students, to get a maximum benefit, you can use this code BHAVANILIVE and join the comprehensive batches. You are also given daily practice papers so that you can practice enough number of questions. There will be full length mock tests with analysis. And remember, for a single subscription, you have unlimited access. There are three, plans we have. Students who are going for 12 months plan, it is at the rate of 12,375, only rupees 1,031 per month. Students who are going for 6-month plan, that is at the rate of 10,125, you have to pay 1,688 per month. There is also offer for new subscribers. Those who want to try for 1 month, you can go at the rate of 2,250. So kindly inform your friends, relatives, brothers, neighbors, sisters, your own classmates, your own juniors regarding plus courses, and whenever they join, let them make use of the code BHAVANILIVE. Okay, students, so we have been on the topic amines. We have been conducting the mock test. There are 2 tests already we completed. So today we are in the 3rd test, that is mock test on amines. So we will be trying to finish as many as questions possible from this topic amines. Students, if you are liking the topic, if you are liking the way I'm explaining, kindly click the like button and also click the bell icon so that you get further notification. Kindly share these videos among all your friends and see to it that large number of students are getting benefited by these videos, okay, these classes. So kindly like, share and subscribe these videos and see to it that you are sending these videos to your fellow friends, your own classmates, or those who are in need of these lessons, these mock tests. Kindly send them and see to it that a big number of students are getting benefit, greater benefit from these mock tests. So let us go for the today's mock test on amines 3. Are you ready? Okay. So we'll go to question number 1, student. The number of structural isomers possible from the molecular formula C3H9N. So you have to write the possible number of structural isomers from the molecular formula C3H9N. You know what is structural isomers means. It can be chain isomer, it can be position isomer, it can be functional isomer, or it can be maybe the metamerism. All these are structural isomerism, isn't it? So you have to write the total number of isomers possible for C3H9N. We have option A as 5, option B as 2, option C as 3, and option D as 4. Students, if you have some answer, you can write it. Okay, so if you have any answer, you can write it, students. Meanwhile, let us try, student. We have C3H9N. So I can write it as CH3, CH2, CH2, NH2. Look here now. C3, H5, H7, H9, N. Okay, one I have written. Now CH3, CH, okay, CH, I'm okay, CH3, CH, I'm bringing this NH2 here, and you have CH3. Okay, this is one more possible. We can have CH3, C, okay. So just see whether this is okay, CH3, CH3, okay, and here CH3, just here C3H9N. One more isomer is possible. Okay, Shekhar is saying answer as option D, that is 4. Okay, we'll try to write one more possible if at all. CH3, CH2, okay, CH3, CH2. Let me make it as NH, CH3. So the possible number, can you write any other, structural isomers? No. You can see here, the functional group is different here. Primary, tertiary, and secondary. Functional group itself different. These are same functional group, but the position of the functional group is different. So all of these are structural isomers. So possible isomers are 4. So answer is option D. Very good students. Okay, we'll go to question number 2. Nitrobenzene on reaction with concentrated HNO3 and H2SO4 at 80 to 100 degrees Celsius forms which one of the following product? So you have to predict when nitrobenzene react with concentrated nitric acid and sulfuric acid. A 1,4 dinitrobenzene, B 1,2,4 trinitrobenzene, option C 1,2 dinitrobenzene, and option D 1,3 dinitrobenzene. So among the 4 options, which option will be the right answer? You can look at the possible product and you can tell me. Very clear, students, this is nitration. The mixture what you have taken here is nitrating mixture, isn't it? Concentrated nitric acid and concentrated sulfuric acid. Together it is known as nitrating mixture. So this is nothing but electrophilic substitution reaction. Correct? Electrophilic substitution reaction. So this will generate NO2 plus. This mixture will give NO2 plus. So we have to now see whether the NO2 plus attack to the ortho position, para position, meta position. So what are the possibility? Okay, so I'm getting one of the answer as A. So let me see. We will try. Before that, let me explain one of the essential parts, student. If you know this one, then easily you can predict. You can use this for other questions also. Let me write nitrobenzene. Okay, as you can see here, oxygen is electronegative. So this electron pair is towards oxygen. So this electron pair shift now. So you have the resonance structure now. And in the resonance structure, student, you have a positive charge here. You have double bond N O minus. Okay, I'm keeping this portion as it is. You have bond here and you have bond here. Okay, now to this bond comes here. The pi electron gets delocalized. So you have a bond here, you have positive charge here, and you have N O minus and O as it is. Now to the pi electron cloud again gets moved. There is a delocalization. So you have here, there is a plus charge here, double bond N O, and you have O minus. Now this will come here and this comes back. You know how to write the resonance. So I have the resonance structure now. You will see a bond here, there is a bond here, and you have here, and N double bond O and O. Now if you see here, student, this is the resonance structure of nitrobenzene. Okay, now the electrophile should attack. Which is the electrophile here? NO2 plus is the electrophile. Now electrophile always attack the electron rich center. Electron rich center. See carefully now the ortho and the para position. You can see here, carefully you see the ortho and para position has positive charge. Whereas there is no positive charge in the meta position in any one of the resonance structure. Kindly see, this is a meta position, and in the meta position there is no positive charge. So what does it mean, student? What does it mean? Meta position is more electron rich compared to ortho and para. Therefore, the electrophile NO2 should attack to meta position. And if it is attacking meta position, what will be the product formed? 1,3 dinitrobenzene. Option D is the answer. So keep in mind, option D is the right answer. Remember, students, whenever the group is meta directing group, then it is meta product. Okay, if the atom which is attached contains a lone pair, then it is ortho para directing. You need to know that whenever the atom which is attached to the benzene ring, if it contains a lone pair, then it is ortho and para directing group. Ortho and para directing group. Whereas here there is no lone pair, this is meta directing group. So answer is option D. I hope it is clear. Go to question number 3. Alkyl halide react with alcoholic ammonia in a sealed tube. The product formed will be tertiary amine, secondary amine, primary amine, and a mixture of all the three. Students, try to predict the product. Alkyl halide and ammonia. You know what happens? Ammonia, therefore you will have the nucleophilic substitution reaction, isn't it? So what do you have? You will have RNH2, that is primary amine. Further, it reacts with alkyl halide. Again, it will act like a nucleophile. So you will have RNHR, that is nothing but secondary amine. Secondary amine will react with alkyl halide. What do you have? Once again, RNRR. This HX is removed. In every case, you can see HX is removed. Hydrogen halide is removed. Here also minus HX. So further, it will react, since in the question tertiary, secondary, primary are given. Answer will be option D, a mixture of all the three. So answer will be option D. So primary amine, secondary amine, tertiary amine. Actually further it can react and give quaternary ammonium salt. So here answer is mixture of all the three. Okay students, we'll go to the next one. C6H5C triple bond N and C6H5 N triple bond C exhibits which type of isomerism? Is it position isomerism? Is it functional isomerism, dextroisomerism, or is it chain isomerism? Students, kindly make a note and tell me, since it's a direct question, I'm expecting answer. Is it A, option B, or option C, or option D? Which type of isomerism is shown by these compounds? One is cyanide, student, and the other one is isocyanide, isn't it? This is phenyl cyanide. Phenyl cyanide. And this is phenyl isocyanide. So what do they what kind of isomerism do they exhibit? Yes, they are functional isomers. Very good. Cyanide and isocyanide, the functional groups are different. They are functional isomers. Option B will be the right answer. Okay. Go to the next question. You are given CS3CH2Cl react with NaCN, sodium cyanide. Product X is formed, which further react with nickel, a hydrogen in the presence of nickel. Product Y is formed. Then in the presence of acetic anhydride, product Z is formed. So you have to identify product Z in the above sequence. So what is Z? You can see here, first one is N-propyl ethanamide. Option B is propyl amine. Okay, so this will be, look at the possibility, student. Is it A? Is it B? Is it C? Is it D? Among the four options, which one do you think you will get it as a right answer? Look at the possibility now. CH3CH2Cl. You can write it in the comment box, students, the moment you get the answer. So you have taken, student, ethyl chloride or chloroethane. React with sodium cyanide. You know what happens? NaCl is removed and the Cn minus will attack the carbon and you are going to get CH3CH2Cn. So you are going to get propane nitrile, or I can say ethyl cyanide. So propane nitrile is formed in the reaction, isn't it? Okay. Further, it is subjected to hydrogenation in the by making use of nickel catalyst. Now when you take hydrogenation, you know what happens in between Cn there is a triple bond, isn't it? So hydrogen is added, correct? So you are going to get CH3 CH2. Okay, hydrogen will be added across the triple bond. See, this is C triple bond N. So when one H is added, one of the bond is gone. 2H added means the triple bond becomes single bond. So you will have CH3 CH2 CH2 NH2, correct? Okay. You will get propyl amine. Then it is reacting with acetic anhydride, CH3CO2O, acetic anhydride. What happens when amines react with acetic anhydride, students? Acetylation occurs. What is acetylation? Hydrogen should be replaced as the acetyl group, the CH3CO group. Therefore, CH3 CH2 CH2 NH, and the hydrogen is now replaced as COCH3. So this will be the final product that is formed. So that is N-propyl ethanamide. I think the first option CH3 CH2 CH2 NS. Okay, so option A is the right answer. Very good, students, you have answered right. It is option A. Go to question number 6. The correct order of increasing basic strength for aniline, and you have N-methyl aniline, and then you have benzyl amine. So you have to, student, find out the correct order of increasing basic strength. Which is strongly basic? You have to keep on increasing. The least basic you keep it at the first, and then you keep the strongly basic now. Now first one given as aniline. First one is aniline. Aniline is a weak base because the lone pair of electron is not available. Why it is not available, student? Because it is involved in resonance. So lone pair is not available. Therefore, this is weakly basic. We will see option 2, that is this one, N-methyl aniline. See, even here the lone pair is involved in resonance, but the only difference is it is attached to methyl group. What is methyl group, student? It is electron releasing group. Since there is a presence of electron releasing group, plus I group, the electron availability on nitrogen will be better compared to the first one. So this will be strongly basic. Among the two, this is the better one because you have electron releasing, or I can say plus I group, methyl group. Now we'll go to benzyl amine, CH2NH2. You can see here, student, the lone pair, the nitrogen here is not directly attached to benzene ring. That means it is not involved in resonance. Therefore, this is freely available, student. It can be donated easily. Therefore, this is a stronger base. Therefore, among the option, see, CH2, NH2, NaCH3, option C will be the right answer. Students, option C will be the right answer. I hope you are getting it. Go to question number 7. Among the following amines, the strongest base is. Now you know among aniline and ammonia, ammonia is ammonia is a stronger base than aniline. That is because in aniline the lone pair is involved in resonance. Now if you take the case of option C, now option C is nothing but pyrrole, isn't it? It is pyrrole. In pyrrole, the lone pair what is present on nitrogen, student, the lone pair which is present on nitrogen is involved in aromaticity. In order to be an aromatic compound, you need 6 electrons. So this lone pair is actually involved in sextet formation. It is involved in, I can say, it is donated. This electron is contributed or donated towards the aromatic character. That means this is not at all basic. Pyrrole is not basic because its lone pair is involved in aromaticity, involved in aromatic character. So we will see option D. Option D is nothing but pyrrolidine. Here you have a lone pair. Okay, so this lone pair can be easily given. It will be easily abstract a proton. Therefore, among the 4, option D will be the stronger base. Option D, that is pyrrolidine, is a stronger base because there is no aromaticity here. Okay, it's not involved in aromatic character, resonance stabilization, nothing. So option D will be the right answer. Okay. Ethylamine and aniline can be distinguished by ethylamine and aniline. A. Sodium hydroxide, B. Beta naphthol, C. Chloroform, and D. Hinsberg reagent. Okay, so among the 4 options, student, which one do you think is the right answer? You have one side ethylamine and the other side you have aniline. So which one do you think is the right one? We cannot think of sodium hydroxide. Now chloroform is answered by primary amine and both are primary amine, student. You cannot. Hinsberg reagent is to differentiate primary, secondary, tertiary. But in this case, both are primary. So can we think of beta naphthol? Is it possible? You see, first aniline should be converted to, if you take aniline, aniline can be first converted to benzene diazonium chloride. You are aware of it. Benzene diazonium chloride. You can subject it to diazotization reaction. That is treating aniline with sodium nitrite and HCl. You get benzene diazonium chloride. Now this benzene diazonium chloride, okay, will be made to react with beta naphthol. Beta naphthol, isn't it? So you will get a product of the type coupling reaction occurs, student. There is a coupling reaction and you will be getting, okay, if you want you can write N double bond N, N2. So you are going to get, student, an orange colored dye. orange color dye is formed. So aniline can give or undergo coupling reaction, whereas ethyl amine or aliphatic amines does not undergo this reaction. Aliphatic amines, primary amines, does not respond to this reaction. Okay, so aliphatic amines do not respond to this reaction, but aromatic primary amine can give a dye. The moment you say, get orange color dye, that means it is aromatic or it is aniline. Therefore, answer will be option B. You can use beta naphthol and you can differentiate the compounds. Okay, very simple question. In the Hoffmann bromide degradation reaction, the number of moles of sodium hydroxide and bromine used per mole of amine produced are. So how many moles of NaOH is used and how many moles of Br2 plus is used? Students, kindly give your answer because it's a very simple question. Let me take amide. Okay, Hoffmann bromide reaction, amide, bromine, sodium hydroxide, this R group will migrate. You're going to get RNH2 and you will be getting NaBr, right? And also you're going to get Na2CO3 plus you're going to get water. So if you are balancing, this should be 4. This will be 2. So how many moles? See, 1 mole of amines are produced. How many moles of bromine is used? 1 mole of bromine is used and 4 mole of NaOH is used. So 1 mole of bromine and 4 mole of NaOH will produce 1 mole of amine. Answer should be 4 moles of NaOH and 1 mole of bromine. Option D will be the right answer. Okay students, so actually I'm going to end my session. So our sessions will be for half an hour. I will be taking my next session on the 5th exactly at 2 o'clock. See to it that you are attending the session. And since you have learned my, listened my class, if you are liking my class, kindly press the like button and also press the bell icon. Share these videos among your friends. See to it that large number of students are watching these classes and getting a benefit. And also inform about the plus courses and ask them to subscribe the plus courses. And whenever they join, let them make use of the code BHAVANILIVE. You can see this will be the code they will be using, BHAVANILIVE. Thank you students. Keep studying, keep practicing and see to it that you are concentrating on competitive level exams. So we will see you once again on 5th exactly at 2 o'clock. Bye students. Take care.